Assalamualaikum. We are from Group 4. We'll be presenting on the elementary particles. So I am Sister Natasha Nisah binti Jaidi with my group mate, Sister Mazliana, will be presenting on this particular topic. First, I will explain on the basic forces. So basically, there are four basic forces that we have to know that scientists have determined, which is first, gravitational force. Gravitational force exists between any two objects with masses. This force binds stars together to form galaxy, and it is always attractive. A galaxy can experience this gravitational pull by another galaxy many light years away, and the magnitude of gravitational force obeys the inverse square law, and it is the weakest force out of all basic forces. And second is electromagnetic force. This force exists between two charges. This force that binds electron to the positively charged nucleus to form an atom, and also this atom binds together to form like solid, liquids, and gases. It is attractive for same charges but repulsive for unlike charges. And also like gravitational force obeys the magnitude of inverse square law. The third nucleus is the strong nuclear force. This strong nuclear force only acts on quarks. This force binds three quarks together to form a nucleon, and then it acts on nucleon to form nucleus. Its range is 10 negative 15 meter, and it is the strongest of the four basic forces. And lastly is the weak force. This weak force only acts on leptons and quarks. It can cause the flavor of a quark to change. A change in flavor can cause a neutron to transform into proton via beta minus decay, and its range is 10 negative 17 meter. And these are the comparison relative strength between the four basic forces. Next, we can discuss on the classification of elementary particles. So basically, elementary particles can be divided into two, which is leptons and hadrons. And this classification is based on the type of fundamental forces that act upon it. So for leptons, the definition of lepton is a particle that does not experience the strong force. This lepton is acted by three basic forces, especially electromagnetic and the weak forces. However, gravitational force is ignored because lepton has very little mass in it. Second is the structure. Lepton is a fundamental particle because of its absence of internal structure, meaning it cannot be subdivided into smaller particles. And lastly, for lepton is there are 6 leptons, each has its corresponding antilepton. Next, for hadron, the definition of a hadron is a particle which experiences the strong force. So if we observe from the table, we can see that leptons and hadrons has many similarities. However, in terms of strong force, lepton have weak force and for hadron have strong force. Next, for classification, classification of hadrons can be divided into two, which is baryons and mesons, which baryons consist of proton and neutron, while mesons consist of pions. Most hadrons have their corresponding antihadrons. For example, we have antiprotons and antineutrons. Lastly, for the quark model of hadron, a hadron has an internal structure. Thus, hadron composed of 2 or 3 quarks. A hadron may be one of the following, which a baryon composed of 3 quarks. Not necessarily all 3 quarks must be different. And second, a meson. It is composed of a quark and anti-quark.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti binti Napiah. I will continue the presentation with quarks. Quarks are fundamental particles, do not have an internal structure similar to electron. Electron also do not have internal structure. Quark commonly found in proton and neutron. These are the characteristics of quark. It has 6 quarks altogether. Next, we will go details about it. First, one kind of quark can be transformed into another kind. Each quark has a corresponding with antiquark. It acts on strong force. Some has smaller mass, and some other has larger mass. This helps to differentiate between the quark. Next, quarks also has either 1/3 or 2/3 of electron charge. Quark is constituent of hadron. It freely moves in hadron without much force acting on and confined in it. Once it tries to move further away, a strong force will pull the quark back. Strong force can bind with one quark and one anti-quark form a meson, while when it's bind with three quarks together, this will form a baryon. For quark family, each of 6 quarks carry a charge. From this table, first, second, and third generation, there's different type of quark and symbols that shows the value of electron charge for each quark. For example, U and D is the symbol for first generation, and it has positive, U has positive 2/3 charge, D has negative 1/3 charge of electron. For second generation, S has negative 1/3 electron charge and C has positive 2/3 electron charge. And the third generation, D has positive 2/3 electron charge and B has negative 2/3 electron charge. We can see clearly here, proton and neutron were at the first generation. Proton and neutron have quark U and D. The strong force binds with 3 quarks together called baryons. For proton, it has quarks UUD. U represent positive 2/3 electron charge, while D represent negative 1/3 electron charge. Thus, the electron charge for proton is positive 1. As well as neutron, neutron have quarks UDD, a bit different with proton. Thus, the electron charge for neutron is 0. Here's some example of hadrons, particles which experience strong force. Hadron was divided into 2 types, baryon, strong force bind with 3 quarks together, and meson, strong force bind with 1 quarks and 1 anti-quarks. This table shows that all the symbols involved and also the quark composition. For this table, we can detect the anti-quark, which is U, that has a straight line above it. Next, we go further to beta minus decay and neutrino. How it's happened. Nucleic carbon 14 is unstable, so it decays by emitting beta minus particles to transform itself into nitrogen. From this graph of number of beta particles versus kinetic energy Ke, we know Ke has continuous distribution, range it from very low value to the maximum value Tmax. This means not all beta minus particles carry same amount of energy. Some carry less amount of energy and some carry more amount of energy, even though it's originated from the same source. The beta minus decay by carbon 14 can be present this nuclear equation. From this nuclear equation, we can see the beta minus particles, which is E, 0 and minus 1, and the anti-electron neutrino that accompanies the beta particles. Neutrino is a subatomic particle with a mass near 0 and a half-integral spin that rarely interacts with conventional matter. The properties of neutrino are uncharged, meaning no electric force, mass almost 0, and there's no gravitational force, and neutrino is a lepton that interacts via weak force. Range of the force is between 10⁻⁻17 meters. They do not leave visible cracks in the cloud chamber and are not deflected by electric or magnetic fields due to their properties. They only interact across a short distance, and the change of them interacting are quite slim. So to detect the neutrinos is challenging for the scientists, despite the fact that there are a lot of them. Neutrinos can be detected in cosmic ray and in nuclear reactor cores. So that's all from us. Thank you.